Hello everyone. What we'd like to do in this video is just get tons of practice with expanding and combining logarithmic expressions using log rules. Again, I can't stress enough, log rules are our best friends. When you get to calculus, sometimes you can attack problems and it's going to take you like pages of work. But if you just would have remembered from the beginning that you can clean some of these expressions up with log rules, man, you can really just make your work just so much cleaner, saving paper, saving trees, log rules, saving the earth. Okay, so let's recall what the log rules say. Okay, if we have log base b of really, I could put anything here. I think I was using n's and m's, n times m. This is the same thing. Multiplication corresponds to addition. 2. Division corresponds to subtraction. And the third one, the star of the show. I don't know if it was m to the n or n to the m, doesn't really matter, it works both ways. Let's do n to the m. Raising something to the power, powers correspond to multiplication. Okay, there we have it, our 3 log rules. Okay, so let's do some exercises. The first one we're going to do here is let's get practice with combining. Okay, combining. These are type of exercises where there are multiple logarithmic pieces in an expression, and we want to try to condense them down to just have a single logarithmic expression, or just an expression that just has a single log in it. So, for example, let's say we have 1/2 times log base 2 of 5 minus 2 times log base 2 of 7. So what we want to do is we want to take this logarithmic expression and we want to condense it down to just having a single log. Pause the video and give this a shot. Okay, let's do it. First thing we need to do is, I guess what you might be tempted to think to do first is use log rule 2. Here it's saying that subtraction corresponds to division. However, be careful that log rule 2, this only works if the coefficients in front of the logs are 1. So notice here the coefficient in front of this log base 2 is 1/2. For this log base 2, the coefficient is 2. I have to use log rule 3 first. So using rule 3 here, this is the same thing as log base 2 of 5 to the 1/2 power minus log base 2 of 7 squared. Okay, maybe we could write this as log base 2. Remember, 5 to the 1/2 power is the same thing as the square root of 5 minus log base 2, 7 squared is 49. Now, since the coefficients in front of these are 1, we can use log rule 2. So using log rule 2, we have that this is equivalent to log base 2 of the square root of 5 all over 49. Now this is tough to evaluate if you want to know what the exact value of this 2 to what power gives you the square root of 5 over 49. I don't know. We'll soon learn how to use our calculators to evaluate something like this. This turns out to not be a nice number. But our goal for these type of exercises is taking an expression that has multiple logs in it and condensing it down to having a single log. So this is the answer. Okay, I want to make a quick note on this problem. The only reason I was actually able to start combining these is because these logs had like bases. If this was log base 2 and this was log base 3, there is nothing we could do. We could not condense this. This would be as simple as you could get it. The only thing you could possibly do with this is use log rule 3. You know, this works with any base. This rule works with any base. So the only thing you could have done with this is this. And you couldn't go any further. I guess you could write that this is 7 squared is 49, and 5 to the 1/2 is the square root of 5. But if these had different bases, you could only really go to here. You can't use rule 2 because these have different bases. This is where you would have stopped. But in the problem, since they did have like bases, we were able to use log rule 2. Okay, let's do one more. Combining. Okay, let's say we have 3 times the natural log of 2 plus 2 times the natural log of x minus a 1/2 times the natural log of x plus 4. Go ahead and pause the video. Pause the video and see if you can condense this logarithmic expression to only have a single log. Give it a shot. Okay, let's do it. The first thing we have to notice is we can't use log rule 1 or log rule 2 yet. To use these rules, I need the coefficients in front of the logs to be 1. All of these coefficients are non-1, so we have to start by using log rule 3. I'm actually going to show you 2 fun ways to do this problem. The first thing I'm going to do here is I'm going to use log rule 3, and I'm going to bring this 3 up, this 2 up, and this 1/2 up. Okay, so using rule 3, this is the same thing as the natural log of 2 cubed plus the natural log of x squared minus the natural log. Okay, this is going to be x plus 4. Make sure you put parentheses here. You should always be paranoid with parentheses. Okay, so this is the same thing as the natural log. 2 cubed, 2 times 2 is 4. This is 8. 2 cubed is 8. Plus the natural log of x squared minus, this is the same thing as the natural log. The natural log of the square root of x plus 4. Okay. From here, I'm just going to work from left to right. Okay. So this is going to be the same thing. Now I can use what? I can use log rule 2. I can use log rule 2. Or how about log rule 1? We can use log rule 1 if we're working from the left to the right. Log rule 1, I can multiply these. So this is the same thing as the natural log of 8 times x squared minus the natural log of the square root of x plus 4. Okay, so I used log rule 1 from here to here. Now I can use log rule 2 to divide. So this will be the natural log of 8x squared all over the square root of x plus 4. And we're finished. This is the answer. Okay, for fun, we could have done this a different way. This is probably the way I would have probably done it the first time I would have attacked this problem. I was probably expecting that this is the way that you would have attacked this problem. But for fun, we could have approached this differently. You know, just to show you that, I don't know, one of the funnest things I think are in math is seeing different ways to approach problems, and as long as you're using the math rules correctly, you should get to the same place. So instead, let's say that you didn't like subtraction. You didn't like subtraction. Really, there is no such thing as subtraction. Subtraction doesn't exist. What is subtraction? When I see to myself 5 minus 3, I say, subtraction. That doesn't, subtraction, there is no such thing as subtraction. This is just the same thing. Subtraction, what is it? It's really just adding negatives. It's really just adding negatives. So when you subtract two numbers, there is no such thing as subtraction. It's just adding negatives. It's just adding negatives. Similarly, there's no such thing as division. Who told you there was division? There's no division. 5 divided by 2. There's no such thing as division. Division is just multiplying by reciprocals. Dividing by 2, what? You mean multiply by a half? There's no such thing as division. Division is just multiplying by reciprocals. So, you may have thought this way, and you said, subtraction, funny. Maybe you said this is the same thing as the natural log of 3 times the natural log of 2 plus 2 times the natural log of x. And you said, oh, that's just adding a negative 1/2 times the natural log of x plus 4. Okay, we could use log rule 3 here. So using log rule 3, this is the same thing, is the natural log of 2 cubed, so that would be the natural log of 8, plus the natural log of x squared. But now this would be plus the natural log of x plus 4 to the negative 1/2. So that's the big difference. Okay, well, let's remember what it means to have a negative exponent. Remember that if you have x to the negative n, what do negative exponents really mean? They mean, usually exponents x to the n. This says take this number x, multiply by itself n times. Negative exponents mean divide. So this means divide by x n times. Okay, so for putting this all together, this says the same thing as the natural log of 8 plus the natural log of x squared plus, this is the same thing as the natural log of 1 over the square root of x plus 4. Well, I guess maybe if you don't like that, if you don't like me doing too many steps here, this is 1 over, this is the same thing as x plus 4 to the 1/2 power. I can get rid of the negative and put it in the denominator as a positive, but 1/2 powers mean the same thing as square roots. So this is the same thing as 1 over the square root of x plus 4. Now I can just slap this thing with log rule 1. Let's just smack this thing with log rule 1. What can we do now? Well, now since it's all addition, we can just multiply this all together. So maybe I'll do it in a 2-step process. We could first multiply these together, or multiply their insides. This is the natural log of 8x squared plus the natural log of 1 over the square root of x plus 4. Well, now hit this with log rule 1 again, multiply. This is the natural log of 8x squared times 1 over the square root of x plus 4. Well, now we can just multiply these together, and this is the same thing as the natural log of 8x squared all over the square root of x plus 4. How fun, how fun, we got the same exact answer. How fun, we got the same exact answer. Cool. Okay. So that's how we can combine. Okay, let's try expanding. Okay, so expanding. Okay, so these are just good exercises. So let's say we have our first example. Really, this is just kind of going backwards. Let's say we have log of x over the cubed root of 1 minus x. Okay. So what we want to do here in these situations is we want to take a single log expression and we try to expand this out as much as possible using log rules. Okay. Go ahead and pause the video and see if you can do this on your own. Okay, let's do it. The first thing I'm going to see here is we need to use, I have an x divided by, kind of think that there are parentheses. The first thing I have to do here, we have to use log rule 2 first. So using log rule 2 first, this is the same thing as log. Remember, when it just says log, that means that this is base 10. It's just log base 10 is so common, we just don't write the 10 there. It's kind of like for square roots, we don't write a little 2 there, and we write a cube root. For square root so common, we don't put that 2 there. This is the same thing as log of x minus the log of the cubed root of 1 minus x. Okay. Well, now the only other thing I can think to do here is actually use log rule 3. We can clean this up here. We should remember that the cube root means the same thing as raising something to the 1/3 power. So I have a 1 minus x to the 1/3. Log rule 3 lets me bring that 1/3 out front. So using log rule 3 here, this is the same thing as log of x minus a 1/3 times log of 1 minus x. And we're done. We're finished. This is the answer. A very common mistake I see that students want to make here is, I see students want to do this a lot of the time. You know, like say that log base x, log of, could be any b, log base b of x plus y. I see students sometimes want to say, oh, this is log base b of x times log base b of y, or something like this. This is not true. This is not true. And they would do the same thing with subtraction. I might see some students, maybe if there's subtraction here, they might think to do this. But this is also not true. This is not true either. Notice when we're looking at our log rules here, there's only a rule for when we have a multiplication, division, or powers inside the argument. There is no rule for addition or subtraction inside of a log. So if we have something like log base b of x minus y, there is nothing more you can do with that. There is nothing more that you can do with that. Okay. What's another common mistake that I see? Another common mistake, I just kind of want to throw it out there, is sometimes I see students, they'll do something like log base b of x minus y, and they might say, oh, I think I already wrote that on the board. I already wrote that. They think it's division. Or maybe something like this. Another common mistake is if I see sometimes log base b of x minus log base b of y. I'll sometimes see students say that this is the same thing as log base b of x divided by log base b of y. This is also not true. When we have a subtraction here, the division has to happen in the argument. This is another very common mistake. I'm just trying to recall mistakes I sometimes see students make here. This is also, I think, a very common mistake. This is not true. When we have log base b of x minus log base b of y, we divide the arguments, not the logs. This is log base b of x over y. So just be careful. Okay. Okay. Let's do another exercise. I'm going to go ahead and erase what we have here. Okay. Let's say we do, how about log base 3, how about of the square root of, how about y cubed all over, how about 2x. Go ahead and pause the video and give a shot at expanding this right here. Go ahead and expand. Okay, let's go ahead and do this. We're going to have to be very careful in situations like this, specifically with parentheses. The first thing we should notice with this problem is that this y cubed over 2x is all inside a square root. So we need to see this as a y cubed over 2x, all to the 1/2 power. All being raised to the 1/2. And now we can use log rule 3. We have to use log rule 3, and we have to bring that power out front. So this is the same thing as 1/2 times log base 3 of now y cubed all over 2x. Okay, what to do from here? Well, we have division. I have a y cubed. We have this y cubed all over a 2x. So I do want to use log rule 2, but I need to be careful because I'm multiplying this entire expression by 1/2. A common mistake I'll see is this. This is the common mistake. We'll write it in red. Red means bad. This is a common mistake I'll see some students make. Because they'll say, oh, this is 1/2 times log base 3 of y cubed minus log base 3 of 2x. Maybe pause the video and think about why this is wrong. Okay. The reason why this is wrong is because we didn't use parentheses. This 1/2 multiplies onto this entire thing. So we have to think that there are parentheses. That there are parentheses right here. I'm multiplying the 1/2 times this expression. Well, since this expression is the same as this right here, I have to multiply the 1/2 times this whole thing. We need parentheses. We need parentheses. So just be careful. Again, you should always be paranoid with parentheses. Okay, so this is the correct way to do it. Green means good. Okay, we would be correct to say that this is 1/2 times the quantity, log base 3 of y cubed minus log base 3 of 2x. Okay, we're getting somewhere. I think we can go even further. We can go even further with this and see what can we do. Well, we could notice that, we could use log rule 3 to bring this 3 up front. So we could write this as a 1/2. Okay, let's bring this 3 out front. So here we're using log rule 3. Okay, so I guess what do we do from here to here? From here to here, I'm trying to write all these steps down. From here to here, we use what? Log rule 1. We use the first log rule. And we were careful with parentheses. And now I'm using log rule 3. Using log rule 3 to bring this 3 up front. So this is the same thing as 3 times log base 3 of y, okay, minus log base 3 of 2x. You can do multiple steps in these problems, when you're doing this at home. Just be careful. I'm doing kind of one step at a time to try to show as much gory detail as I can. Okay, so I'm going to kind of erase a little bit. I need more room. Or maybe what we can do is let's take this and bring it up here. Okay, we'll continue the work here. Okay, now the only thing left I can see to do here is maybe use log rule 1 again. Notice I have multiplication inside of the argument. I can separate that with addition. Again, I'm going to write a common mistake. A common mistake I see students make with these. We'll write it in red. I see students will say, okay, we got the 1/2. We have the 3. We have the log base 3 of y. And then okay, this is minus log base 3 of 2 plus log base 3 of x. It's like, oh, I'm just using log rule 1 to break this up into addition, but I've made a mistake. Maybe pause the video and think about what mistake we made. Or a mistake I made. I made it up here. Okay. Parentheses. I'm subtracting. We're subtracting. When I'm breaking, I'm subtracting this entire piece. So if I expand this piece, I need to subtract all the parts. The mistake we made is I forgot parentheses. Okay. So this is incorrect. We made a mistake here. Let's write in green what it should be. What we should have done, or maybe I'll write it right here. We got some room here. Can we see from here? Okay. So we do want to use log rule 1, but we needed to make sure to use parentheses here. So this is the same thing. This is the same thing as the 1/2. 1/2. We have our parentheses here. We still have the 3 times log base 3 of y. Okay. Now we should be subtracting and in parentheses. Maybe I'll use these type of parentheses here. We have this is log base 3 of 2 plus log base 3 of x. So we needed to make sure to introduce parentheses. This minus sign, sign right here, needs to distribute. We have to subtract all the pieces. So what we should have after using log rule 1 is we should have, well, I'm running out of room here, but we want to distribute that minus sign. So we'll have a minus log base 3 of 2, and then we'll have a minus log base 3 of x. And this here is the answer. This here is the answer. Now it's really up to you. It's really up to you if you want to distribute in this 1/2 or leave it just like this. So you could leave your answer just like this if you want. I don't need this parenthesis here anymore. You could leave your answer just like this, or if you want, you could distribute in this 1/2. And so we could equivalently have, that would be what? 3/2 times log base 3 of y minus 1/2 times log base 3 of 2 minus a 1/2 times log base 3 of x. I would say that this answer or this answer for me would be equivalent. Okay. So what should we say here? Be careful with parentheses. Be super careful with parentheses. Here's something fun we could have done. I can't help it. I'm just seeing other ways to do this problem. Maybe you did plus the opposite. Maybe we did plus the opposite. Maybe from here instead, we said that this was, how about we think about this as plus the opposite? And we could think that this right here, this is like a -1. This is like a -1 times log base 3 of 2x. So just for fun, what you could have done, just to show you get the same answer, is this -1 here. Using log rule 3, we could bring this into the parenthesis. So this would be the same thing as 1/2. Where we're going to get log base 3 of y cubed plus, this would now be the same thing as log base 3 of 2x all to the -1st power. Okay, there's nothing wrong with doing it like this. Okay, well, maybe close a parenthesis right here. Okay, so it's almost like I'm condensing and then I'm going to re-expand. But notice that this is the same thing. This is the same thing as 1/2 times log base 3. I guess I could have brought that 3 out front. Okay, of y. And this is, well, this piece right here, we have log base 3 of 1 over 2x. This is equivalent, since I have a division. This is the same thing as log base 3 of 1 minus log base 3 of 2x. So this is the same thing. Well, this is saying, what is this saying? This is saying 3 to what power gives you 1? I hope you believe that 3 to the 0 gives you 1. 3 to the 0 gives you 1. So log base 3 of 1 is 0. So this is 0 minus log base 3 of 2x. Well, I guess maybe we're kind of maybe going a roundabout way. We're just playing around. Minus log base 3 of 2 plus log base 3 of x, and then distribute the minus sign. Minus log base 3 of 2 minus log base 3 of x, and you could take this piece right here. Put it back right here, and you'd be getting the same exact answer we had before. I don't know if this was really necessary for me to do here. It was just something I saw. I just kind of wanted to play around and kind of see where we got. Maybe doing plus the opposite and bringing that -1 up here. Maybe this definitely wasn't a helpful route to take, but kind of fun to see that you would get the same exact answer if you played around a little bit. Okay, let's do another example. Let's do one more. Okay. Let's try to expand. How about the natural log of, how about the cubed root of x squared plus 4 all over y times z to the 4th. Go ahead and pause the video and try to expand this. Okay, let's do it together. The first thing we need to notice is we have to use log rule 2 here. I'm dividing two quantities, so I want to have natural log of the numerator minus the natural log of the denominator. So using rule 2 here, we'll get the natural log of the cubed root of x squared plus 4. And now we're going to be subtracting the natural log of y times z to the 4th. Okay, so we use log rule 2 here. Okay, we can use log rule 3 to bring the 1/3 power out front. So we're going to use log rule 3 here. So this is the same thing as 1/3 times the natural log of x squared plus 4 minus the natural log of y times z to the 4th. Here is another common mistake that I see students make from here. Well, I'll see some students do, we'll write it in red, is specifically on this piece right here. We're saying, I see something being raised to the 4th power. I see something being raised to the 4th power. So what I see some students want to do here is write this as 4 times the natural log of y times z. This is incorrect. Maybe pause for a second and think about why this is wrong. The answer is we have to remember a convention with exponents. Exponents only act on what's directly next to them. This is what this is saying here inside this parenthesis. This is saying y times z to the 4th. This is saying y times z to the 4th. So the 4 is only hitting the z and not the y. If this was y times z to the 4th, this would have been correct. When would this have been right? This would have been right if the problem was the natural log of yz, and both the y and z were being raised to the 4th power. Then going from here to here would be correct. The problem here is I can't use log rule 3 here because this 4 is only hitting the z and not the y. I am eventually going to use log rule 3, but we have to use log rule 1 first here. So be careful. Be careful. So this here, what did we have? We had a y. We want to think about this as y times z to the 4th. So we have to use log rule 1 first. We have to use log rule 1 first. So we have a 1/3. We have the natural log of x squared plus 4. Log rule 1 says this is the same thing as subtracting. Okay, I'm going to break this up as a sum. I'm subtracting. We need parentheses. We need parentheses right here. We're subtracting. I got to subtract all the pieces. So here we're going to subtract. This is going to be the natural log of y plus the natural log of z to the 4th. Be a little bit careful. Okay, we need to subtract all of the pieces. Okay. Now from here, the subtraction sign can distribute to each of the pieces. When I subtract a sum, we have to subtract all of the pieces. Okay. Now we can use log rule 3. Now log rule 3 says that this is 1/3 times the natural log of x squared plus 4 minus the natural log of y minus this 4. This 4 can go out front. So this is minus 4 times the natural log of z. And this is the answer. This is the answer. Okay, why can't we do anything more with this piece? I see an x to the 4th. I'm sorry, I see an x squared. Can we use log rule 3 there? Nope, we cannot. The problem here The problem here, if this was just the natural log of x squared, yeah, you could bring the 2 out front. But it's x squared plus 4. Again, notice that there is no rule up here that talks about what to do when there's addition inside of a log. There isn't a rule for that. So once we're here, we're done. We can't go any further. So this is the answer. Okay. I hope you enjoyed this video. I hope you're starting to get a little bit more comfortable with using log rules. They're really our best friends. We're going to be using these here to start solving log equations and exponential equations. We'll see you there. Take care.